Good morning. This is Miss Millerbeth, and we're going to talk about like terms and unlike terms. So these are all examples of terms. So we can have terms with variables with an exponent of 2, or we can have a constant term, or we can have a term with a variable to the degree of 1. We usually don't write a 1 there, but there's a 1 for an exponent. So there's a lot of different ways to write terms. So let's group these. I'm just going to circle the terms that are like. So we're going to start with 3x squared. So 3x squared, that's similar to negative 5x squared because it has an x squared and a coefficient in front of it. All right, let's look at 4y. What's similar to 4y? There it is, negative y. So this has a y and that has a y. And it happens to have just coefficients in front of it. In fact, this one has a coefficient of 1. We just normally don't write that. All right, let's look at negative 7. This is a constant term, so it has no variable. So we need to find another constant or a constant term, and 10 happens to be it. And now when we look at, let's see, negative 2x. Well, it's like 8x because they both have an x, and the degree or the exponent is 1. So there's really a 1 right here. We just don't write it. Just like with the y, there's really a 1 right there. We just don't write it. All right, let's look at the next part. So we need to look at what are terms, coefficients and constants. So if we have an expression like this, 7x squared minus 3x plus 4, let's write the terms. So our first term is 7x squared. Our next term is negative 3x. So we don't want to forget that that's a negative. So really it's plus minus 3x. We just don't write plus minus, so we write minus instead of plus minus. So that's a negative 3x. And then our last term is 4. So coefficients only occur if there's a variable. So we look at the ones that have variables. So here's a variable, so the 7 is the coefficient. Here is the variable, right here, x. So negative 3 is the coefficient. 4 is not a variable because it has no, 4 is not a coefficient because it has no variable. So 4 is called a constant term. So again, 4 has no variable, so it can't be a coefficient. So it is a constant term. It stands alone. It really has a little x to the 0, but we won't really talk about that right now. That's for later math, like in high school. All right, here's a grouping of like terms and unlike terms, just so we can work through several types of examples. So we have a negative 2a and 11a. Well, they're like because they both have an a. These are unlike because this has an a, but this has a b. So they're not like variables. So they're unlike terms. We can't combine them unless their variable is exactly the same with the same exponent. So these are like terms, x squared, 7x squared, and negative 5x squared. It doesn't matter about the coefficients in front. It only matters about the x squared. So this one we have x squared, but now we have just x. So it's missing the same exponent on that one. So these are unlike terms. These would be constant terms, so they have no variable, and that's a constant term, but then this one has a variable. So we can't combine a constant term and a variable term. Now, when we look at this one, we have an xy variable pair, but both of them have an xy variable pair. So we have 9xy and minus xy. So here we have xy, but then we just have x squared. So that is not the same. All right, let's look at this one. We have negative p squared q and 3p squared q. Well, p squared q is the same thing. And we have p squared q here, but here we don't have p squared q. We have pq squared. Oh, that's so close, but it's different. Okay, so they're not like. So we have to be very careful. Where is this exponent? Is it with the right variable? So that's something you have to look at when you're comparing like terms. All right, let's work through some examples. So first, we're going to combine this. So these are like terms. They're all like terms. So we're just going to combine it using PEMDAS. So first, we do addition because there's no multiplication, division, parentheses, or exponents. So we start with addition. So 5 plus 6 is 11, and it's t. Now we have 11t minus 7t. Okay, well, what's 11 minus 7? 4. So this is going to be equivalent to 4t. Now notice I'm not writing an equal sign because this is an expression. Expressions don't have equal signs. So let's do the same thing with this. So we have negative 4bz minus 3bz. So negative 4 minus 3, that means we're getting more negative in the bank. So if we minus $4 in debt and we spend $3 more, we're now $7 in debt. So we have negative 7bz plus 5 halves bz. So what we want to do is get a common denominator. So we're going to multiply by 2 over 2. So that gives us negative 14 over 2 bz plus 5 halves bz. And then we add the tops, so negative 14 plus 5. So we're negative $14 in the bank, and we deposit $5 in to get our debt to be less. So the other thing we can think of is different signs take the difference. So we take 14, which we know is negative, and 5 is positive, and we subtract. Okay, so because they're different signs. So we're going to carry one here, so we have negative 9. So this is going to be negative 9 halves bz, and we don't want that equal sign. Okay, there you go. So, oh, and with this one, it's same sign sum that we did here. So we added 4 plus 3, and then kept it negative. So same sign sum, and then different signs take the difference. So remember those two little ways to remember when to add and when to subtract the coefficients. And we always keep the sign of the biggest number. So if the biggest number is negative, like 14, then the answer should be negative. All right, so we have 3 minus 8. So we have different signs, plus, minus. So we're going to do different signs to take the difference. Well, what's 8 minus 3? That's 5. And the bigger number is negative, so it's a minus 5n. And now we have negative 5n plus 5n. Okay, so if we add negative 5 plus 5, that's 0n. Or otherwise known as, doesn't that look like on? But it's 0n. Okay. Okay, so simplify. So when we have two different terms, a great way to do this is to box the terms that are like, or use some sort of method to isolate the terms that are like. And when we have a term like this, we want to take the sign with it. Now the next one, what we're going to do, since we used the box, let's use the circle for this one. Okay, so we have 5c minus 3c minus 4d minus d. Okay, so 5c minus 3c, so 5 minus 3 is 2. So we have 2c, and then we have same sign sum. So this is really, there's a 1 right in front of there. So negative 4 minus 1. So you've had $4 in debt and you had to spend that dollar. So now you're more in debt. So that's negative 5D. So now our final answer is 2C minus 5D. All right, this one gets very complicated, so we need to be very good with our boxes. So we're going to take a box around this and look for another AX term, and we always take the sign in front. And then this one, we're going to circle negative 7x, and we see that there's a negative 2x that has the same variable. Finally, we have a constant term, so we'll just underline that. Okay, and now let's put them all together next to each other. So 2ax plus ax, which is really 1ax. Let's make that a nice little plus right there. Okay, then we have minus 7x minus 2x plus 3 halves minus 5 halves. I'm going to make some room here because we're going to have to do some like denominators. All right, so when we combine these, we have 2 plus 1 is 3ax, and negative 7 minus 2, so same sign sum, so 7 plus 2 is 9, and they're both negative. So this one is going to be negative 9x. And then this one, we need a common denominator. So let's multiply this one by 5 over 5, and this one by 2 over 2. So that's going to be, we'll do this in another step. So we have plus 15 over 10 minus 2 over 10. So we have 3ax minus 9x, and then 15 minus 2 is 13 over 10. So that's how we would simplify that one. Right, that's it for section 4.1. You have a wonderful day.